In this skill, we're going to be looking at correct Lewis diagrams and looking at the number of electrons to figure out what's unusual about these molecules. So firstly, we have BeBr2, shown in the diagram, 1 beryllium atom and 2 bromine atoms. So let's just go to our periodic table and have a look at those. So beryllium is here, and bromine is here. So beryllium is in group 2, bromine is in group 17. So according to our shortcut, we know that beryllium has 2 valence electrons, and we know that bromine has 7 valence electrons. So we have beryllium with 2 valence electrons. We have bromine with 7 valence electrons. And let's just add up the total that we should have. We've got 1 beryllium atom, and we've got 2 bromine atoms, which means we have 1 set of 2 valence electrons plus 2 sets of 7 valence electrons, which gives us a total of 16 valence electrons. So we should be seeing 16 valence electrons on our diagram. Let's count them now. We've got 1 pair there for a total of 2, another pair providing another 2 for a running total of 4, another pair there providing another 2 for a running total of 6, a covalent bond here providing another 2 for a total of 8, another covalent bond here providing another 2 for a total of 10, and then we've got 3 more lone pairs here, each providing 2. That's 6 more electrons for a running total of 16. So we have a total of 16 electrons on our diagram, which makes sense because that's what we should have based on our periodic table and the number of valence electrons from each. Now let's look at our individual atoms. So first let's look at this bromine atom here, which is labeled bromine atom 1. Here we've got 3 lone pairs and 1 covalent bond, which each provide 2 electrons. So that's 8 electrons in total for bromine atom 1. And that makes sense. That's what we expect according to the octet rule. Bromine atom 2 is the same. We've got 3 lone pairs, 1 covalent bond. That gives a total of 8 electrons, which again is what we expect according to the octet rule. Last, let's look at our beryllium atom. Here's beryllium. Now beryllium has 2 covalent bonds and no lone pairs. Each covalent bond provides 2 electrons, so that's a total of 4 electrons on our beryllium atom. Beryllium here seems happy to just have 4 electrons in its valence shell. So we're asked, in what way does this molecule demonstrate an exception to the octet rule? Well, beryllium is the exception, and it seems to be stable with less electrons, so a reduced octet. So instead of 8 electrons, beryllium seems happy just to have 4. So what we'll find in this skill is that there are some elements in the periodic table which have exceptions to the octet rule, and they're happy with less or more electrons than we're used to with the normal 8 for the octet rule.